If you're a database developer, you must have come across the term row level security or RLS. If you have heard about it but you're not sure what it is or how it works, then this video is for you. Hi, I'm Bindu Kumar and I welcome you to my channel. In this video, we are going to learn what is RLS, why is it so important, what are the different ways of setting up RLS, and what are the pros and cons of each approach. Let us begin with a very quick demonstration of RLS or row level security in action. Here, you'll see I'm using the database client, which is dbeaver, and using this, I've connected to my local Postgres database. But I've created 3 separate connections to the same database. As you can see on the left side here in the database navigator, there is a Postgres default, there is a Sigrid, as well as there is a Zelda. So all of these 3 connections are to the same database. However, all 3 connections use a different username. So you'll see that here, if I click on the edit connection, you'll see the Postgres is of course using the Postgres username, and the second connection, which is Sigrid, is using the Sigrid username, and then Zelda is using the Zelda username. So we have 3 connections to the same database, each of them using a different username. Now that we know about the connection, what we're going to do is, against each of these connections, we are going to run the same query and look at the result. So we're going to start with the first connection, which is the Postgres default. And here, it's a very simple query. It's just returning the total row count from the employee table. Let's execute this. And as you can see, the total row count that is returned is 10 million rows. Now, let's switch to the other session for Sigrid. And here again, it's the exact same query, select count of star from employee. If I were to run this, you may expect 10 million, but no, it returns 40,930 records. And we're going to do the same with the third connection, which is Zelda. And here again, you would expect 10 million, but no, it returns 40,070 records. So what is happening? Why is it that it's the same query when executed through different sessions against the same database returns different data or different row count? Well, this is the magic of row level security. So now that we've seen the demo, let's actually understand how this is set up and how this works. So now that we have seen RLS in action, let's quickly understand what is RLS or row level security. Imagine a table here with 8 records. And let's say we have a user, green user, and this green user should only have access to rows 1 and 2. Maybe because this has confidential information and the green user is only authorized to see data that's the first and the second record. Similarly, there could be an orange user who should only have access to the rows 6, 7, and 8. And there could be a blue user who should have access to the rows 2 through 6. So how do you set up a rule that ensures that the users can only see the data that they're supposed to? And that feature of a database that supports or that enables you to set up this rule is called a row level security. So now that we know what RLS is all about, let's set up RLS from scratch. So to begin with, we need some tables on which the RLS can be applied. So here, for demonstration, I'm using 2 tables. One is an employee, the other is a country manager. So let's look at this data and the schema, and then it'll be easy for us to understand how RLS works as well. So the first table that we're going to look at is employee. Imagine this is data about a company that has branches across the world in every possible country, and it has employees in all these countries. So this table is a list of all employees working in every country, but for that organization. So here you see the UUID, which is, you can think of this as the employee ID. You have the first name, last name of the employee, and the full address of the employee as well. And then what you also get is the country name. So here, what it says is that the employee belongs to this particular country or is employed in this particular country. And of course, for every employee, it will be exactly one country at any given time. So this is about the employee table. Then moving on to the second table is the country manager table. This is somewhat similar to the employee. Here, there is one record for every country in which a branch exists, and for that country we are also storing who is the manager for that country. So here you can see there is a UUID. You can think of this as the primary key for this table. Then there is the country name. Then you have the manager first and last name, and followed by the user ID. And here every country has exactly one manager. So this is about the table. So now we are back in our database client. We have this first query, which is select count of staff from employee, and this returns the total row count of 10 million. And this is fine when this query is being run by, let's say, an admin who has access to all the data. But let's say we have this Zelda, who is a manager of Samoa. When this manager of Samoa country runs a query, she should not be able to see all these 10 million records. She should only see the records that or the list of employees that belong to Samoa, and nothing more than that. Well, if she runs this query without any filter, it's going to return 10 million. But what we want the database to ensure, right? We want the database to apply a rule in the background so that only the Samoa country employees are returned to her. So in effect, the database should apply this additional where clause. So when this filter is applied, it only returns 40,000 records. And you can see what this filter is all about. What we are saying is, from the employee table or on the employee table, add a filter on the country name, and the value for this country name should come from a subquery, and this subquery is select country name from the country manager, where the manager user ID is Zelda. So this filter has to be applied in the background without the Zelda being without Zelda being aware of it, right? That's how this rule is supposed to work. Otherwise, Zelda can go ahead and make this change herself. Similarly, when Corey logs in, Corey should not be able to see all the 10 million records. Instead, he should only see the list of employees who belong to Netherlands, because Corey is a manager for Netherlands. So now how do we enforce this rule? The first thing that we need to do is, in Postgres, there is a setting or a configuration called row level security, which needs to be enabled on every table. And the way to do that is, it's a very simple command. You just say alter table and the table name, and we say enable row level security. Now, once this is done, we need to create users. So now that we have enabled row level security on the employee table, the next step is to create individual accounts for these users. Now you might ask, why do we need these individual accounts? You see, if you're an employee, you have an ID card, and you go and let's say you swipe it at the entrance to your workspace, right? And that's how the company tracks who is the individual who has logged in or logged out at a specific time. Similarly, in order to identify who is the person who's logging into the database, you will need to create individual user accounts. For example, we have 244 managers in the country manager table. We will have to create 244 individual accounts for these managers, so that when they log in, database identifies that yes, it is Diana that's logging in, or it's Zelda that is logging in, and then it can apply that specific rule. So the database limits the data that a user sees depending on their user account. Now let's go ahead and create our accounts. Creating an account in Postgres is pretty easy with this command. You just say create user, the username with the password. So here I'm just using the same username as the password because this is my personal laptop. It's a mock-up data, but definitely in your organization, especially if it's a live database with company data, you never should create a password that's this easy to guess. Always create passwords as complex as possible. So with this command here, I'm going to execute this. You can see now that the user is created. Now let's connect to this database as this user to see if the access works. So here I'm going to go to the database navigator, copy this connection and paste it again here, and we will rename it to Zelda. And then let's edit this connection. So the username will be Zelda_tempora and the password is the same. I'm going to test the connection. Everything works fine. So now we have created a user, we have created a connection as well. Let's use this connection to open up a new script or a new session. And once I'm here, let's actually expand this to see if we can see the two tables. So yes, as you can see, both the employee table and the country manager table are visible. Now I'm going to do a select star from the employee table. Okay, so we get the error, permission denied for table employee. Let's try the other table, which is the country manager. And we get the same error for this as well. So what it shows is that when you create a user in any database, by default, the user doesn't have any permissions other than just the ability to log into the database or create their own tables. So in order for them to be able to access existing tables, permissions have to be explicitly granted to them. So let's see how that works. So granting permissions to a table for a user is pretty straightforward in PostgreSQL. We just need to execute this command, the grant command. So you can see the grant is the command, it's the keyword, and it says grant select on. So what kind of permissions do you want to give to the user? Is it a select? Is it an insert, update, delete? Here we want the user to be able to just query the table, hence the select is enough. So we're saying grant select on. So here we specify the target table, in this case it's employee, and then we say to which user. Here of course it is to Zelda. So it's grant select on employee to Zelda tempora. So I'm going to select this and hit enter. You can see now the permissions have been granted. Now let's quickly switch to the Zelda session and we will do the select star from employee. So if you do that, you see now we are no longer getting the permission denied error, right? Instead, a data set appears, but it's only the headers. There is no data within this result. So what does it mean? It means that the table is there, the data is there. However, Zelda still doesn't have access to the data. She has access to the table, but not to the data. Why? Because we have already enabled the row level security on the table, right? Now let's try another thing, right? We will we'll see if Zelda can access the country manager table, but no, that error is still there, which is the permission denied error. Let us go back and here we will grant this, right? Grant select on country manager to Zelda. Now let's come back and when I run the select query, bingo. Here she not only sees the metadata, but she sees the data as well. And you might ask that why didn't data appear for employee, but it only appeared for the country manager? Well, the reason is we have enabled the row level security only on the employee table, not on the country manager table, because the employee table is the one that is having the confidential information, not the country manager. You know what we learn from this is the moment you enable row level security on a table in Postgres, until you define the policy, no user is going to see any data. I mean, they might see the table, they might see the metadata, but that's about it. They will not see a single row because we have not specified the policy, right? The policy with which a user will be able to see data. So until that policy is defined, Zelda will not see any data from the employee table. The most she can see is just the columns appear in the table. Now let's see how to define the policy. So by now, you know, everything in Postgres is pretty easy. Creating a policy is easy as well. So here you just use the command create policy and you mention the name of the policy and make sure it's meaningful on the target table, which is employee in our case, and then using. So after using, you see a expression. It's a SQL expression. And this is the most important part because this is going to decide for every row, whether it should be accessible for a certain user. And this is an expression that we have already seen a couple of minutes ago, where I showed you this query, right? What is the query that we need to use, or rather, what is the filter that we need to use to limit the amount of data that a specific user sees? It's the same expression you can see here using country name equals. So the moment we mention country name here, what we are saying is this country name is a column in the employee table, right? So country name equals, and then we are saying select country name from the country manager, where manager user ID equals current user. Now, this is the most important part. You see, earlier when I showed you the exact same query, we had hard coded a very specific username like Zelda or Corey and so on. But here in a policy, we can't do that, right? Because the policy is generic. It has to know based on the user that is logging in at that specific time or through that specific session. So what we do is we use this variable or session variable called current user. Now, how does this work? I mean, for those of you who are aware of session variable, this needs no explanation. But in case you are hearing about the session variable for the first time, this is something that's there in most applications or most server software. And database is a server software after all. What happens is when a user connects to the database, when a user initiates a connection, the database captures some important details about the user. For example, what is the IP address through which the user is logging in? What is the username that the user is using? What is the kind of a role, and many other parameters, right? We will not get into the details of it, but once it captures, it makes it available through the session variable. So you can actually query these session variables as if they are just another table or column within your database. So here, what happens is when a user, let's say Zelda logs in to this database, her username, which is Zelda Tempora, is captured and it is stored in the session variable under the variable name current user, right? So you can think of the current underscore user as a keyword within Postgres, right? So you shouldn't really use this to name any of your columns in a table. This is a column that's already used by Postgres. Anytime you query the current user, it will tell you who is the user who is logged in. So we are using that variable here. Okay. Now imagine if Zelda logs in, she initiates a connection. Her username is captured in this current user. And when this policy is applied, Zelda is applied as a filter, right? This current user is replaced by Zelda Tempora, which is the actual value. And that is applied as a filter to the manager user ID column of the country manager, which in turn returns exactly one row, which is for the country Samoa. And then this Samoa value is applied as a filter here for the country name of the employee table. Hence, the employee table will now return results only for the Samoa country. So that's how the create policy works. Now let's run this policy. As you can see, the policy is created. There were no errors. Now let's query this table from Zelda's session and see what the data looks like. So now let's get into the Zelda session, and the query is still there, which is the select staff from employee. If we execute it, now all of a sudden we see data, right? Before this, there was no data. So first step, there was no data, or rather it was permission denied. Second step, the table was visible, but there was no data. Now in the final step, Zelda is able to see some data, right? And here, if you observe, the country name is all Samoa, right? At least what is the, the data that's visible in the screen right now, it's all Samoa. Let's confirm this, right? So we will do a count of star. And now you can see it's only 40,000 records instead of the total 10 million records that are in the table. Now I also want to look at the country name. Is it really only Samoa, or is it something else as well? So let's do the country name and group by one. So if you see, Zelda is only able to see the Samoa country's employees, which total to 40,070 out of the 10 million that are there. And the best thing here is Zelda does not have to apply any filters, right? Any, she is not playing around with, let's say, where clauses. All of that is being done in the background by the database using two things. One, the row level security that we have enabled, and two, the policy that has been defined. So this is how a row level security works in the PostgreSQL database. You enable the row level security, you enable the policy, and then every time a user logs in and queries the database automatically applies these policies or filters in the background, giving a very seamless experience to the user. I mean, the user does not even realize that they're getting to see just a limited amount of data. So this is what we refer to as database-based RLS or row level security. So now that we have seen the database-based RLS in action, let's summarize it by looking at what are the kind of situations where it's useful, and also the pros and cons of this approach. So here I've created this simple diagram. You can see you can put yourself in the shoes of the database admin or someone who's responsible for setting up the database. So here is the database admin. On the left side is the database, and let's assume that the resource, which is the database, as well as you are in the same control plane. And what I mean by this is that you have total influence and control over this database, meaning you decide how people access it, how many accounts to create, and so on and so forth. In this situation, you have the complete flexibility to set up the database-based RLS. So here you can see these users at the bottom, right? These users are a representation of the users who want to connect to the database. And notice that when they connect to the database, it's not just a straight connection, but rather every time they connect, there is a RLS policy being applied. Probably they are aware of it, they may not be aware of it, right? But this RLS policy is something that's completely managed by you. So in this situation where you have complete authority over the database, it gives you that flexibility to set up a database-based RLS. But then you might ask, what if I don't have control over the database? What if I'm not an admin, right? There is another solution for it. We will discuss about that in a couple of minutes. So for now, let's look at the pros of a database-based RLS. First is audit friendly. So what is this auditing? See, auditing not from a, let's say, from a commerce background, but in the software industry, what audit means is that due to this increase in storage of confidential data, increase in hacking, increase in data leaks, and so on and so forth. From time to time, organizations measure how secure their applications are. How well are you implementing the best practices from the industry, and so on. And this process of analyzing a system and making observations and sort of capturing the records, right, that is called audit. And when an audit team inspects a database, and when you tell them that, look, my database is accessed by 100 people, they would automatically expect that you have created 100 accounts. Why? Because when you create a database account and when somebody logs in, the database through its logging mechanism, it can store who is the user who logged in, from which machine, what is the IP address, what is the client, what was the last time they changed their password, what were the queries they run. The complete history is available, and this is what audit team really looks at, which is why when it comes to auditing, they are very comfortable with this database-based RLS. In fact, in most cases, they would recommend that a database should not be accessed in any other method apart from creating accounts and then creating the row level security. Next is central point of control. So you as a database administrator have complete control on creating accounts, so that way you decide who gets to access the database. Second, through creating these policies, you can also decide what is the level of access they have, whether they can select records, whether they will be able to insert, update, or delete records. So you have a very granular control over the tables. And when I say these insert, update, delete, it's not just on the entire database. You can define it at individual table levels, which gives a great degree of control over how your database is used. Next is, as I said, very granular permission. So most databases provide this row level security. It's not just the select, but they let you decide. They let you as an admin decide where if a user can insert, update, delete. But for me, it's not just the create, read, update, delete, but it's the selection of the actual records itself. So as you see, although there were 10 million records, we created such a policy where Zelda was only able to see 40,000 records, right? So a subset of the data can be returned to the user. So that is what we meant as very granular permissions. The next is works very well with other BI tools. So imagine your users are not accessing the database directly. Instead, they're using some kind of tools like Tableau, Power BI, and other reporting tools out there. Well, these tools connect to the database, and when they do, if the user uses the same database account details, such as Zelda, so Zelda, instead of directly connecting to the database, she connects to it through Tableau, and while she's connecting, she's logging into the database as Zelda, and that's the credentials she's using there. So the moment you set up a database-based RLS, it really doesn't matter whether the user is directly connecting to the database or if he or she is using some kind of a client tool like Tableau or Power BI. The permissions are still applied, right? So that way, a database-based RLS is very well integrated or works very well with these other BI tools. And the last benefit of this is it works very well in situation where users want direct access to the database. As I showed in the previous slide, when users say that, no, I don't want to use any other tool in the, let's say in the middle as an intermediate, but I want to be able to directly connect to the database and query it. And trust me, in a lot of organizations, this challenge exists where there are these data scientists or data analysts who are very comfortable with writing SQL and they want direct access to the database. But then the DBAs or database leads, they come in between and they say, no, we can't give you access to the database because you will run queries and you'll see all the data. We have confidential data there, right? And because of which they'll say, okay, if you tell me what data you want, I will export it and give it to you as a CSV file. This, in my perspective, is a very poor way of collaborating or sharing data in an enterprise, right? So here we can make use of the database-based RLS. Now, let's rethink the situation. A data analyst wants to access your database and he or she is comfortable with SQL. Create an account for them, set the permissions, test it, and then share the credentials with them. Let the data analyst directly access the database and run their queries. Right, so that way you're making their, let's say, you're making them productive, right? They don't have to deal with data files in data in CSV format or some other weird formats. You're directly giving access to the database, so that way they are also happy. They don't have to reach out to you every time they need a new data export. They can connect to the database and they can run their queries very well, and so that makes them happy. And when they are productive and they are happy, they give good feedback about you and they feel good about the way database is being handled. And in my perspective, the row level security exists for that very reason. We shouldn't limit the users. We should limit maybe the data, but we should not limit in terms of capabilities. If they want to run SQL, we have to support them, and the database-based RLS is what makes it possible. So now that we've discussed the pros of database-based RLS, let's look at some of the cons or the shortcomings of it. So first is supports limited number of users. Now, this is a major problem. When you're using a database like proprietary database like SQL Server or Oracle and so on, there when you purchase these database, you are paying for a fixed number of users. Like for example, if I buy a SQL Server database, apart from a fixed fee, I'm also paying them on the number of users, right? Let's say I'm expecting 50 users. So I'm paying Microsoft 50 users, which means I'll be able to create 50 individual accounts in my database at any given time. I will not be able to create any more accounts above it, right? So now let's say I have a SQL Server database, I have set up 50 users, and I have defined the RLS. Now another 5 users come and they say, hey, you know what? We also need access to the database. Can you please do it? But no, I can't, because adding additional users means purchasing additional licenses, and these licenses are super expensive, right? So most organizations don't do it, right? Instead, what they do is they will create a shared account, right? And or rather a common account, and then share the credentials with all those 50 users, which is a pretty bad idea. But unfortunately, in order to set up a database-based RLS, you need to have individual accounts. Otherwise, it simply doesn't make sense. The next step is to implement RLS. There is this mandatory process of onboarding and offboarding of users. Now, what does this mean? You see here, in my demonstration, I created a user Zelda by just running a simple command, one line command. But in real world, it's not as easy as that. You see, before you can create an account in a database, there are often many steps that you have to go through. You have to link that account with, let's say, the Active Directory account, because you have to show that this account is not just for someone, it is for someone who is an employee, right? And their entries there in the Active Directory. So that you will have to do. And then before you can actually create the account, you will have to go through a set of approvals where managers, senior managers, data owners, they all approve that yes, it's okay to give this person access to the database, right? So there is a couple of steps that you need to do before you can onboard. Similarly, when that employee leaves either the organization or the department, you have to go through a reverse process of making sure the privileges are removed, the account is removed, and so on. So maintenance wise, this is a bit of a headache, right? And there's no escaping that. You have to do this if you want to set up a database-based RLS. Next is regulations around account creation, right? Again, with so many data leaks and hacking going on, the regulations have become even more strict around database access, because databases have a wealth of data. So which also means it slows down, right? Before you can create every account, you have to go through a huge checklist, either you or the users, or maybe both of you, right? You have to go through a huge checklist to make sure, okay, you're conforming to everything, like changing passwords very often, making sure there are no concurrent logins, and so on and so forth. So the more accounts you create, the more headache for you as an admin, because now you are responsible for it, right? Even if there is one account that is being used multiple times, it's considered a severe violation in many organizations. So there are quite a few regulations that come into the picture when you have to set this up. Next is restrictions from upstream databases. See, it's not always that you are in control of the database. Many times you don't own the database, right? You may be supporting a bunch of users, but the actual database may be managed by some other team. And when you go to this team and say, hey, you know what? I have 10 users. Can you create these 10 accounts in your database? They will straight away decline it, because you are not the only team for them. There are probably 10 to 15 other downstream systems that they're dealing with, right? So especially when databases are not in your sphere of control, it becomes very challenging to convince them to create accounts. So, and that is a situation where a database-based RLS simply isn't going to work out, because they will not create accounts, they're not going to create any policies. And then limited support by SQL-based databases. You see, the row-level security is only supported by a small set of relational databases. The moment you start exploring NoSQL databases and other databases, yes, there are policies, but they work in a completely different fashion. And this row-level security may not be supported by every database that uses SQL. For example, Apache Trino, Apache Presto, which are SQL engines. These engines may not have the concept of a database-based RLS. So that is an evaluation you have to do. If you think that you need RLS, and before you pick a database technology, you have to evaluate. You have to see if the database supports that. And finally, the maintenance. So to summarize all of this, so as you can see, the moment you get into this database-based RLS, it comes with a lot of benefits, but also shortcomings, right? Especially on the maintenance part. There are a lot of things that you have to do routinely in order to ensure that nothing is missed, and the users are there. The users are not sharing credentials. They are only seeing the data that they need to. And now I showed you just an example with two tables, employee and country manager. Often databases have thousands of tables. Now imagine managing permissions for one user for those 1,000 tables and multiply that by another 1,000 users. So it's very easily said than done. The maintenance really becomes a bottleneck. But of course, there are tools, there are frameworks through which you can manage, especially in a larger team. When you have bandwidth available, you can still manage this, and it's not as bad as I say it. So far, we have seen the pros and cons of the database-based RLS and how it works. Now, as you can understand, database-based RLS is not suitable in every scenario. I mean, it's suitable in very specific scenarios, but in situations where you cannot create accounts or you don't have access to the database, it's simply impossible to set it up. So what is the alternative? And that's what we're going to look at now. There is one other alternative which we refer to as data-driven RLS, which can be used as an alternative method in case database-based RLS doesn't work. Now, before I can demo that to you, let me run some queries. So here I want to show you that in the database, there is no other user account apart from the Postgres. And I'm running this query, select star from pgcatalog.pg user. You can see for yourself that there are no accounts. So whatever accounts I have created earlier, like Zelda, Corey, all of that has been dropped. And I also want to show you that there are no policies. Remember, earlier we created an employee underscore policy. All those policies have been dropped as well. So this database is as good as a public database, meaning anybody with the admin access can connect to this database and they can look at all the data. Now observe this query. Select count of star from RLS underscore employee. See, this is not the employee table, but this has the prefix RLS underscore. And then curiously, unlike a table, this is accepting a parameter, right? It says admin. So let's just run this and see what happens. So you can see it returns the 10 million records that is expected from, let's say, the employee table. But this is not exactly a table, right? Because it's accepting a parameter. So this must be a function. But let's run the second query. Select count of star from RLS employee. Here we are passing Zelda tempor as the parameter, and it returns 40,000 records that was earlier visible with when we had the policy and when we tried to run it as Zelda. This is the count that we used to see. And now again the same query as Corey. Now Corey sees only 40,420 records. So what exactly is this? I mean, we haven't created an account, we have not created a policy yet. The data is being filtered. So to understand this, we have to look at this function. So you see, the RLS employee is not a table, it's a function that I have created. And I assume that you know what a database function is. So in this function, I'm accepting a parameter, which I'm calling it as logged in user. And it's a very simple select statement inside the function. It does a select star from employee, and it applies the where condition, which is exactly the same as we looked at before. It's the same where condition, maybe with some additional input values to handle admin login. And here we are applying the same filter. So something that we used to do using the session variable, now we are doing it using the parameter value. So when this function is executed, and we pass the username as the parameter, we get the data that only the user can see. So this is how a data-driven RLS works. So in situations where you cannot create accounts, you cannot create policies, but at the minimum, you can create tables and you can create functions, definitely you can use this data-driven row level security. So we have seen the data-driven RLS. It's pretty straightforward. I mean, it's just that all the logic you take away from the policies, row level security, and you just embed it into a function. Now let's see what are the scenarios where this is more suitable. Imagine you are the database admin, but the database that you manage is not the one that the user needs. Imagine the database is managed by someone else in a different team and hence in a different control plane. What you can do is, if your users want to access this database, you can't let them directly run queries. You need to have some kind of an application here. I'll give you an example. Imagine a scenario where you have built a web application. Let's say it's a dashboard, and you want your different users to access this this dashboard. However, based on the user credentials, you want to limit the data that is shown in the dashboard, right? You don't want to show all data to all the users. So what you can do is, you enable the users to log into the dashboard, and you would have written the dashboard logic in such a way that the dashboard will send queries to the database, and there, instead of doing a direct select from the data from the table, you do a select star from this function. And as you can see in the function, you are already passing a parameter, and function is taking care of limiting the amount of data, right? So this is called a data-driven RLS. So here there are some pros and cons for this approach as well. Remember always, there is never one good approach. Every approach has a pros and cons, and as a good developer, as a good data architect, you must be aware of the pros and cons of every approach. Now let's look at the benefits of this. The first benefit is highly flexible. You see, you are no longer limited by the features that are available within the database. You are completely enabled by the SQL features that are available in the database. So what are the kind of SQL that you can write? That's how flexible your row level security is, right? So that way the data-driven RLS is highly flexible. Next is, you don't need user accounts anymore, which is a very big benefit that you gain from this. Of course, it's not audit friendly, but the fact that you can now use a common account, but yet you can enable these very specific RLS without having to create the individual user account. So that's a very big benefit to be gained. Next is, you don't need additional permissions on the database. So as long as you can create tables, you can create functions, you can define this RLS. Next, it works with any SQL compliant database, and this, in my perspective, is a very good benefit, because there are many database engines, like for example your Hive, Apache Trino, Apache Presto. These are SQL engines. They may not implement an RLS within their engine, but if you can create a function, if you can create a table, then you can build an RLS system using this data-driven approach. And then finally, it's highly scalable. You see, now you're no longer limited by the number of accounts you can create for that license, right? You might have a database that only supports up to 10 user licenses, but you can in reality create millions of users, or let's say you can support millions of users who will query your database. And this is not just I'm saying it with a very short demo. This is something that I've done in my project, where we support hundreds and thousands of users without having to create a single account for them in my database. Then let's look at the shortcomings of this approach as well. First, the queries can get complex. So as you can see, it was not a simple select star from a table. It was a select star from a function, and then this function had to be parameterized as well. Now, it makes your queries definitely complex, but does it make highly complex? No, I think it's manageable. For a decent database developer, it shouldn't be a big deal writing this query. However, troubleshooting can be a little complex. Why? Because it's not only the select query that you write at the surface, but you also need to look into the function itself. What is the select query that runs inside the function? Because of which it makes the coding a bit complex. The next is, this is only useful when users don't need direct access to the database. But let's assume that some user says that, you know what, I don't want to use these dashboards. I want to directly access the database. I want to be able to run the SQL queries myself. Well, there the data-driven is not going to work. You need the database-based RLS. This again is a challenge I've seen in many places, where users want to directly access the database, but you simply can't do that because you have not set up a database-based RLS. And coming to the third point, because users are not directly querying the table, right? Instead, you're querying a function, and the function in turn is querying a table underneath, right? Because of this, there is definitely a performance penalty. I mean, this is fine when your volume of data is less, when you have less number of tables and less number of joins. But as and when all of this increases, you have more tables, you have more joins, you have more data, then definitely these problems become bigger, right? They become bigger to a point that you just can't handle it with a data driven, and you'll have to switch to something else. Either you increase your database resources, or you switch to a database-based RLS. Coming to the audit topic, of course, as you can imagine, the auditing team hates this. They don't like this data-driven RLS because you're not creating accounts, and the dashboard can always be manipulated. I mean, developers themselves can now access all the data in the database using the shared account. So audit is never a big fan of this approach. And finally, this doesn't work well with BI tools, and I think this goes without saying. If you have something like a Tableau or Power BI, those tools are simply not aware of how to leverage a function. They still query a table where all the data is available. So in places, in projects where you have to use a reporting tool like Tableau and Power BI, this is simply not an option for you. So with this, we have covered both the database-based RLS and data-driven RLS. Let's quickly conclude them by comparing both the approaches on few parameters. So the first is flexibility. As I've explained, the database-based RLS supports medium level of complexity, where data-driven RLS can support a high level of complexity when it comes to the logic. I mean, the kind of processing that you want to do. And when it comes to troubleshooting, which is the next parameter, database-based RLS are quite difficult to troubleshoot, right? And I'll give you an example. Imagine a user says that, when I log in, I am supposed to see 50 records, but I only see 25 records. And now you as a developer, you are supposed to troubleshoot it. But the problem with this is you cannot log in as that user. You can't ask the user to share his or her credentials, and then you can log in and check. That's simply not going to happen. Even if it does, it's a compliance violation. So troubleshooting becomes very difficult. Now you will have to go through the policy, you will have to go through the rules within the policy, and so on and so forth, which makes troubleshooting highly difficult. Whereas in data-driven RLS, it's very easy. Again, I'm speaking from my experience. When a user says that they're not able to see some particular data, it's very easy. I mean, you just run the function by passing this user's input, or rather user's username as a parameter, and you can immediately troubleshoot it. Coming to the third point, the audit, which we have already spoken, database is highly preferred by the auditing team, whereas the data-driven is not so suitable for them. Coming to the fourth point, the database independent. Like, how dependent are you on the database technology? Database-based RLS is 100% dependent on the database. Whether you're using SQL Server or Postgres or something else, the database has to give you those features. Otherwise, you simply cannot set up a database-based RLS. Whereas in the data-driven RLS, it's completely database independent. The only thing you need is that database must support SQL, it must support functions. As long as both of these are available, you can easily set up your RLS. Then moving to the fifth parameter, the team independent. How dependent are you on some other team? Imagine, you don't own the database, some other team does. So when it comes to database-based RLS, you are 100% dependent on this team, because when you have to onboard a new user, when you have to create a new policy, you always have to reach out to this other team and request them to do this. There's a high degree of dependency on this team, which actually slows you down a little bit. But when it comes to the data-driven RLS, it doesn't matter whether you own the database or it's owned by some other team. As long as you can deploy tables and functions, you have the complete ownership, you have complete control, and very less dependency on this other team. Then the next parameter, which is the compatibility with other tools like business intelligence tools. As explained already, a database-based RLS is highly compatible, whereas the data-driven is nowhere compatible, or it has very less compatibility, or it needs a lot of engineering to make it compatible. And finally, the code simplicity, which in my perspective is often underestimated, right? It's not only about building a great architecture, but it's also about thinking how easy is it for your developers to use this technology and use this framework. So database-based RLS is very easy. I mean, it's pretty straightforward. It makes your code very simple and clean to maintain. However, the data driven can get very complex, especially when you have lots of joins, you have lots of lots of tables and all. Your code becomes very complex very quickly. So this is something that you have to be careful about. So with that, we have come to the end of this video. I hope you found this useful. I mean, I've come across a lot of developers who have been working in databases for a number of years, but they don't understand what is row level security, and that's the reason I chose to make this video. Because with the increase in the adoption of databases, with the increase in storage of confidential data, all of us have to have this awareness and experience with row level security. This is not some advanced topic. I feel this is a basic topic that every database developer should be aware of, and hence I spent this time. It took me a couple of days to make this video, but I hope it was worth it. I hope you found it useful, and then you were able to follow each and everything that I mentioned along with the demo. So if you found it useful, please do give a like, share it with your friends and colleagues who might be new to this topic as well, and make sure you subscribe, because I'm going to make more videos on this very same topic. And if you have any questions, if you have any comments, if you think you have a very different scenario where none of these approaches fit, please let me know in the comments. I'll be more than happy to take on the challenge and come up with a solution for your unique problem. Thank you, and see you in my next video.